Hello everyone, welcome to Easy Geotech. This is the first video in this channel and I hope it's not the last. In this short clip we're going to examine the ways that MIDAS GTS-NX is able to get forces and moments from 3D solid elements. We know already that MIDAS GTS-NX provides a direct plot for forces and moments for 1D and 2-dimensional structural elements. But the question is here, how do we get these quantities from 3D modeled elements? For this procedure, we have basically three ways to get this done. The first one is the virtual beam method. The second, the LDF sum, and the third, gauging shell element method. So now here in this video we are going to examine the three ways. For the virtual beam method we have here a situation with a pile with a layered soil. Now we go to element create, delete, and we create the virtual beam, and for this purpose we select the whole pile. And now we select the center of the pile. And we go to the other extreme of this 3D element. And now we have just defined an axis, which is called virtual beam in this case. And it generated a mesh set, the virtual beam mesh set, as we can see here. So this is the axis of our pile. So now we just go to the stages of our project, and in the stage of piling we just need to add this new mesh set called virtual beam, not in piling. So here we have just created our axis for the model. Now we are going to examine the second case, which is the LDF method. So for this case, we have here a situation with a slope, a simple slope, with some piles installed. And so now here we are in the mesh sets. We are going to isolate the piles. So we want to see the forces and moments in one of these piles. So we're going to select some elements, this portion. So we hide the rest. And now that everything is hidden, we go to LDF sum in the result label. We add a plane and we select a plane by selecting simple certain nodes in our model. So we get 1 point here, one node actually, another node, and we have the 3. So we just have defined a plane here. So this is our plane. So here the plane in green. So we can get the results in this certain plane, and we got the forces and moments in X, Y, and Z. Now we have our third method, the gauging shell method. So now we just go to properties and we define a gauging shell property. So we define it. Here we have an example of a foundation with rafts. So basically we have to create this element. So we basically create it from the geometry. We go to the geometry panel, and from there we just select the gauging shell. We select the solid and the faces we want to extract. And here we just have created a gauging shell mesh set. So we just need to add this new mesh set in our stages of construction. So we go here in the raft structure and we add this new mesh. So we just need to solve now the situation. We wait a little bit until the solver gets the result. And we can see from here that we are going to have a result. So we go to the result panel. We activate the gauging shell, we isolate the gauging shell mesh set in order to see the results in this custom mesh set. So we can see here that we are going to see the moments and forces in the raft actually. So we have everything available, bending moments, forces and so on in the surface of the raft. So this is very useful to get the forces and moments in a 3D element like this raft in this example. So yes, as you can see, everything, shear forces, etc., bending moments, forces, membrane force, and that's it, as you can see. Yes. So this is it. I hope you liked it, this video. Thanks so much for watching, and if you liked it, please subscribe, share and like our video so we can start uploading more and get motivation from this. Thank you.